function, this is no calculator too.
Okay.
Given the function f of x equals x squared plus 4x plus 6, rewrite into standard form, or standard and in parentheses vertex form, and find vertex and axis of symmetry and graph.
Okay. Tell me what the general format of the vertex format is.
Vertex format.
Right there. That's the general format.
Okay.
If we can get this function into this format, then we'll know what h and k is the vertex.
Okay.
So we'll know what the vertex is. But in order to switch this function into this format, we need to complete the square. Okay? So let's go down here and talk about completing the square. Do you know how to complete the square of this?
No.
Okay, well, let's separate everything that has an x in it and put it in parentheses and leave a little space. So I've written the thing slightly different, but it's exactly the same thing. Okay?
Okay.
Call that y or f of x. Either is okay. So we want to complete the square. The way you complete the square is you take half of the coefficient of the x term and square it. Well, what's half of 4 squared?
Of 4 squared?
What's half of 4 and then square the result?
So 4.
Okay, so I'm going to add 4. I'm always going to add here. Now I just changed the equation. I just added 4 to it. So if I want to keep it the same as it was originally, I got to subtract 4 from it also. You see that? Where when I added that plus 4 in there, you can't just arbitrarily do that. But if I subtract 4 from the same side, then I've really just added 0, and I can do that. Okay? You with me? Now, the reason I took half of that and squared it was so that I can now write this quadratic as x plus 2, half of whatever that was, quantity squared. Combine these two numbers and I get plus 2. Well, I just turned the whole thing into this format. What's A?
1.
What's H?
2.
It's negative 2. Notice that in my general format, it's x minus h. It's going to be x minus h for the rest of your math life. It's not going to be x plus h. Okay? So it doesn't matter whether you're talking vertex format or the equation of a circle or the equation of an ellipse. It's always x minus h. Okay? So h is minus 2. What's k?
2.
So the vertex is where? What was the question again? What are you supposed to determine?
Here, rewrite into standard / vertex form. Find the vertex in the axis of symmetry and graph.
Okay. Well, there's standard vertex form right there.
Okay.
Axis of symmetry is what? It's a vertical line. In other words, we're talking about a parabola that h is minus 2. K, what was k again?
2.
Okay, so k is plus 2. So there's the vertex, minus 2, comma 2. And does this parabola open up or down?
Up.
Okay, so if that's the vertex, it's got to look like this. Something like that. maybe not precisely like that. But so when they say line of symmetry, they're talking about the imaginary line that goes directly through that thing to make the parabola symmetrical about that line. What is the equation of that line?
X equals -2.
Yeah. That's the axis of symmetry, is x equal -2. So we've got the vertex, we've got the axis of symmetry. What else did they ask for?
Yeah, let me see. So what's the vertex then?
Vertex is always that spot right there. And we've solved for it because we got this thing into vertex format, and vertex format tells you h and k. H has to be -2 because of that, and k is +2 because of that. So that tells us our vertex is at the point -2, 2, right there.
Okay.
Also tells us that the line of symmetry runs right through the x-coordinate. So x equal -2 is the equation of the line of symmetry. What else did they want?
And I wanted to graph it.
Okay, well, we graphed it. Right there. Are there any x-intercepts?
Just negative.
What does that mean? The fact that it doesn't have an x-intercept.
That it doesn't cross the...
Means there are no real zeros.
Ooh.
Meaning that this thing has only imaginary solutions. This equation right here does not have real solutions. There are no numbers, no real numbers for x that make that whole thing 0.
Okay.
And that translates to a graph that doesn't cross the x-axis. In other words, if this graph was like that, well, now I know I have 2 real solutions right there. But, or if the graph was upside down and crossing the x-axis, I would have real solutions. But if the graph does not cross the x-axis, whether it's this or the way we have it, it merely means that you don't have any real zeros, you only have complex zeros. And complex zeros don't intersect with the x-axis. So the only thing that we really need to graph this, right now we only have 1 point, right? So I really don't have any way of telling whether the graph looks like this, or maybe it looks like this, or maybe it looks like this. So I need 1 more point. 2 points do determine a parabola. What's another good point to know? What is that point? If we look at the original function, where does it cross the y-axis? What is x? What is x when we cross the y-axis? What's the value of it? Here, let's look at the curve. What is x right there?
0.
Okay. That's an important consideration, because what that means is that the y-intercept is always this number, because when you plug in 0 for x, both of these terms disappear. So when x is equal to 0, y has to be equal to 6. So now I know that that occurs at 6. And in fact, the points on that are 0, 6. And that's all I need to graph it. If I know where the vertex is and I know where one other point is, has to go through that. And then I know it's symmetrical on the other side. So I could figure out this point over here. What is this point right there? Opposite the 6. it's minus 4.
Yeah, negative 4, 6.
Yeah. In other words, the only thing we know about that point is it's equidistant from the line of symmetry. And this point here was 2 units to the right of that, so I got to go 2 units to the left of that. And of course it's the same y value because it's symmetrical. So actually they usually ask you to give 3 points of a graph. And that's 3 pretty good points. The vertex, the y-intercept, and the opposite point symmetrical to the y-intercept. If you had a graph that looked like this, then the 3 most valuable points would be the vertex and the x-intercepts. That would totally determine the shape of that graph.
Okay.
So it kind of depends on what kind of graph it is, what it looks like, whether there are x-intercepts or not. You got another one?
Yes. Write the third degree polynomial with the roots of -2, 1/3, and 3.
What's the third root?
Negative or positive 3.
If these are the roots, what are the 3 linear factors that I'll multiply together to get this third degree polynomial? If I said to you, x minus 7 times x minus 9 equals 0, what are the zeros? X equals
7
what?
and 9.
7 and 9,
X
right? Okay, so they're asking you to go backwards here. They're giving you the zeros and asking you to come up with the linear factors. So what are the linear factors for us?
So x equals, or x plus 2, x minus 1/3, and then x minus 3.
So those are the 3 linear factors that have to equal 0 because they gave you the zeros. That's why I know it has to equal 0. So to get the third degree polynomial, we just multiply these 3 together. Now, that's not that easy to do. Let's do it. Let's do the 2 easy ones first. Foil those 2 together, or multiply them together, however you want to call it. What do you get? What's the first term? Jade, did I lose you? I think I lost you. It looks like you went offline here. You will need to probably log out of GoToMeeting and log back in. You will probably need to log out once you Yes, period. But you may need to log out first. What are you eating off my floor, huh? What are you eating off my floor? Get that toy. Get that toy. Right there. Get that. Get it. Get it. Get it. Get it. Get it. Get it. Oh, got it. Now, go chase it. Get it. Get it. Get it. Get it. I'm going to try hiding Jade, are you back?
Yeah, okay.
Okay.
I
Yeah.
don't know why it did that. My computer's, like, this blue screen popped up on my computer, and then
Ooh,
just, it shut off, so.
the deadly blue screen. Man, that's called the blue screen of death.
Yeah, I was like, it was weird.
It's a good
Anyways,
thing your computer restarted. A lot of times it won't when you get the blue screen.
yeah, it like restarted by itself.
Wow. Okay. Well, it shows you correct now. It shows the other Jade was offline, but now it's got just you in there. Okay, so let's get back to multiplying these three linear factors together.
Okay.
Since the middle one has a fraction in it, let's do the first one and the last one first. What does that give us? X plus 2 times x minus 3.
X squared minus 3x plus 2x plus 2x squared.
The last term is the 2 times the minus 3.
Oh, minus 6.
Okay, and then simplify this.
So, x squared minus x minus 6.
Good. So now we want to multiply that by x minus 1/3. Now, this is where you can't use FOIL, but you do the same thing as foiling it. You multiply every term by every term. So what's the first term I've got?
X
Cubed. Right. In other words, every term by every term, I'm going to follow the order. I'm going to take the first term, multiply it by that, and then I'm going to take the first term, multiply it by that, and then by that, and then take the second term and multiply it by all three. So let's write down what we get here. X cubed, what? What's next?
Minus 1/3 x.
No, always finish this one. Do all three with that one, and then do all three with the second term.
Okay, so minus x squared minus 6x.
Now do the 1/3 times each.
Okay, so would it be minus 1/3 x squared plus 1/3 x, and then plus, I don't know what that is.
2.
Oh,
Okay? So, now all we have to do is combine some stuff. So, we only have one x cubed. What's the total amount of x squareds we have?
2.
Well, we got 2 of them, but that's minus 1, and that's minus 1/3. What does that add to? Or what is that?
Minus 1 1/3.
Or 4/3. So, minus 4/3 x squared. Takes care of the x squareds. Now we got how many x's total? Plus sign there.
So 5 and a...
That's a good way to do it. 5 2/3. Plus or minus?
minus.
Okay. Minus 5 2/3 x plus 2. Now, the 5 2/3 I can write as 17/3 if it makes you feel better. Now, that all has to equal 0. So, that could be my answer. But I can make it a little prettier answer if I multiply both sides by 3. Notice that I turn all my fractions into whole numbers. And why can I do this? Because 0's on the other side. If I multiply it by 3, it stays 0. So if I multiply every term by 3, I get this. There's your polynomial without fractions. Although this is also a satisfactory answer. Although, did they give any other conditions? Did they just say, write the polynomial?
Yeah.
They didn't say anything like, make sure the coefficient of the x cubed term is 1 or 3. Because a lot of times they'll do that. They'll say, they'll give you the 3 zeros, and they'll say, come up with the polynomial, but make sure the constant is not 2, but 6. Oh, when I multiply everything by 3, I didn't multiply this by 3. That's supposed to be a 6. Excuse me. In other words, I have to multiply every single term by 3 to come up with that. Okay. So either of those two answers is correct if they didn't put any other conditions on what the polynomial had to look like.
Okay.
Okay.
So the next one is well, it says determine if -2 is a root, so that means I just have to do synthetic division, right?
Yes.
Okay, so I know how to do that, so we don't need to do that.
And the thing that goes in the square is the root. What was the question? Determine if square root of 2 is a root?
No, just determine if -2 is a root.
Okay, then you put -2 in there.
Okay.
Okay, in other words, you always put what the root is, not the factor, the linear factor. The linear factor would be x plus 2. But when you're doing the synthetic division, you put the answer in that little box.
Actually, yeah, we should do this one, because I don't know.
What's the polynomial?
2x cubed plus 3x squared minus 8x minus 12.
Okay, the only reason I put the numbers, or the variables up there, was because whenever you're doing synthetic division, you have to make sure that you allow for every degree of x. This has already an x cubed, an x squared, and an x. So I don't have to worry about it. I won't write that in there. But if one of them was missing, let's say there was no 8x, then I would need to put a 0 there.
Okay.
I need a dummy variable if you don't have every degree. Okay? Won't work otherwise. Now what? And what makes this a solution? We have to produce a 0 right there.
Yeah.
Okay? What's the first step?
It says to find all the rational roots and factor.
We're going to do it.
Okay.
In other words, what is across the top here is a cubic. Once we divide that by this root, we're going to be left with the remaining quadratic. And then we can find the roots of that easy, even if we have to use the quadratic formula. But first of all, let's make sure this is a root. What's the first step?
So drop down the 2.
Goes here.
So then it's -2.
-4. You got to multiply that times that to get that.
Oh,
And then it's always adding. What goes here?
-1.
No, we're always multiplying this times that to get the next number.
2.
Okay. So a 2 goes up here. Add those. Gives you -6. Multiply that times that to get +12. Add those to get 0. So what that means is that -2 is a root, which means a factor is that. Well, my remaining factor is that quadratic. 2x squared minus x minus 6. And now we have to see if we can come up with roots of that. In other words, this could be an irreducible quadratic, but it doesn't look like it is. It looks like it has real roots. In fact, I know it does. How do we figure out how to come up with the factors of that?
Do you
We could
multiply
try.
the two?
We could try factoring it. That's still that. Let's see if this factors into two things. What goes here and what goes here?
X?
Well, it's got to multiply to give you that. Whatever goes there and there has to multiply together to give 2x squared. So
2x.
there's two things that multiply together to give 2x squared. What are my signs?
Plus and minus.
Okay, but it could be plus and minus, but it might be this. And it's different because these have different coefficients. So we have to consider both plus minus or minus plus. Now, I need factors of 6, right?
Right.
Well, there's two sets of factors of 6. There's 3 and 2, and there's 6 and 1. Let's try 3 and 2, and let's just randomly try it. Does that produce a minus x in the middle?
No.
It does. How do I figure out what the middle term is? I multiply the insides together, I multiply the outsides together, and I add them together. Well, the inside is plus 3 times x, so that's plus 3x. The outside is minus 2 times 2x, that's minus 4x. Add those together, you get minus x. That is our middle term. That does factor that way. So now I erase that minus sign and that plus sign. I've got all three factors now. I multiply all three of those together, I get the original cubic polynomial. So, what are my solutions? What are my three zeros?
X equals -2. And 1 1/3. Or, yeah, 3/2. 3 halves.
Negative 3 halves. In other words, we're setting 2x plus 3 equal to 0 and solving that equation. Which means 2x equals minus 3, x equals minus 3 halves. Okay, and what's my third solution?
+2.
All right. Is that all they wanted to know?
Yeah.
Okay. In other words, if you start with a cubic and you know one of the zeros, you're going to be able to divide that zero into the cubic to come up with the other quadratic. In other words, it always reduces it by 1. If you start with a quartic and you divide it by a linear factor, you'll be left with a cubic. So it's good to know that if you have one solution of a cubic, you can solve for all three, because you can always reduce it to the quadratic, and then you can use the quadratic formula if necessary. In other words, if that thing didn't factor nicely, I would have just plugged it into the quadratic formula to come up with my other two solutions.
Okay.
All right. What else you got?
What's the remainder theorem?
The remainder theorem says that if something is a factor of a polynomial, the remainder will be 0. Remember the last problem we just did? We were testing to see if minus 2 was a factor, and the way we proved that it was we actually divided the original polynomial by this solution. And to prove that minus 2 was a solution, we had to get 0 right there. That's the zero factor theorem. That means if I produce any other number, if I produce 0, it means it is a factor. If I produce any number other than 0, it means it's not a factor. Not a solution.
Okay.
So that's what the zero factor theorem means, is that you have to get 0 in this last spot here for that to be a solution.
Okay. Okay, divide the polynomial. So x cubed minus 5x squared minus 3x plus 25 by x minus 3.
Did I write it right?
Yes.
Okay. I'm going to do this synthetically, or do they want you to do it by long division? Because you can do it either way.
Well, it had it with the polynomial over x minus 3. So I think that's long division.
Let's do it by long division, and then we'll do it by synthetic division also if you need to review that.
Yeah, I don't know how to do any long division.
Well, the same way you do all long division. We were to divide it by x minus 3, correct?
Mm-hmm.
Okay. You start by dividing that into that. And that's all. Forget the 3 for a moment. What's x into x cubed?
X cubed.
X squared. Right? In other words, we gotta come up with an answer that when we multiply it back by the x, we get x cubed.
Okay.
Okay? Now we take this and multiply it by both terms. And just like in long division, we next subtract. In other words, long division is all about subtracting. So subtract this minus this. What do you get?
Negative 8x squared.
You got minus 5 minus a minus 3.
Oh, so negative 2x squared.
Bring down the next term and stir and repeat. Don't stir, but repeat. So what goes up here next? In other words, now start from scratch again. Divide x into minus 2x squared.
So 2x?
Minus 2x. Again, we got to make sure that that times this is equal to our minus 2x squared.
Okay.
Okay? And it is. So now I multiply that by both terms. Minus 2x squared plus 6x. Subtract again.
So negative 4x squared, or no, that's
Minus 3 minus a positive 6. What is that?
negative 3, or negative 6, or no, negative 9.
Okay. We know this goes to 0 always. The whole purpose of, in other words, when I checked to see if minus 2x was correct, it was only because that times that equals that term. So I know that's always going to go to 0. This goes to minus 9x. I bring down the 25 and repeat again. X goes into minus 9x plus 25 how many times?
Negative 9.
Multiply back. Plus 27. Notice that I do not get a 0. If x minus 3 was really a factor, I would have a 0 here. But instead, I got 25 minus 27. That's a minus 2 remainder, which means my answer is x squared minus 2x minus 9. That's the quadratic, with a remainder of minus 2 divided by this x minus 3. In other words, my answer is x squared minus 2x minus 9 minus 2 over x minus 3. That's how you deal with the remainder, is that's just added. In other words, and because it's a negative, 2 over x minus 3, I would subtract it from the answer.
Okay.
All right, now let's see why synthetic division works. Remainder of 2. Okay? Synthetic division takes the answer, which is 3, and divides it into the coefficients only, And then instead of subtracting every line, we're going to add. Because we're not dividing by a -3, we're dividing by a +3. So that allows us to add. So I bring down the 1. 3 times 1 is 3. Add those two together. Multiply. Add. Multiply. Add. There's my minus 2x squared minus 9 with a remainder of 2. Excuse me. It is 2x squared minus 9x minus 2 with a remainder of 2.
Okay.
Is that what we got the first time?
Yeah.
We got minus 2x squared minus 9x minus 2 with a remainder of 2. Yeah. Okay. So we better get the same solution. You got to get the same solution if you synthetically divide it or if you long division divide it. Once you get really comfortable with synthetic division, it's almost always easier to do that. And the same thing, even if I'm doing long division, I have to allow for dummy variables. In other words, if my thing was x cubed minus x, well, I got to stick in a 0x squared minus x plus 10. In other words, if I don't have an x squared term, I got to allow for it. Even in long division, I got to do it. Same thing as I have to do in synthetic division, is I got to use that 0 up there. All right, what else you got?
It says to simplify, in parentheses it says -3 plus 2i, close parentheses, and then it says times 5 plus 10i.
Just FOIL it. What's the first term?
So -15
What's the next term?
plus 10i.
No, we're going to multiply this times that.
Oh, minus 30i?
Just like we would if it was x plus 2 times x minus 3. In other words, we're still going to do every term times every term. What's the next term?
Plus 10i.
And the last term?
And then 20i squared.
And what's I squared equal to?
-1.
Okay. So now let's combine that real number with that real number, because that number is minus 20. So what's minus 15 minus 20?
-40.
Well, negative 35.
Oh, yep.
And then combine your two i's.
Minus 20.
Minus 20i. And there's your answer. Standard format for imaginary numbers is a plus bi. This is the real part, and that's the coefficient of the imaginary part. So a is minus 35, b is minus 20. Okay?
Okay. And then it has the same things in parentheses except for it says to add them now.
Okay? Adding is very simple. Just multiplication is simple. Adding and subtracting is even simpler because you just add or subtract the real parts and add or subtract the imaginary parts. So if I put a plus in between that, my answer is what?
2 plus 12i?
Not plus. Oh, excuse me. Yes. 2 plus 12i. Sorry. Yeah, it's that simple. Subtracting would be the same. If I subtract them, subtract each part separately. What's minus 3 minus 5?
-8.
What's 2i minus 10i?
-8i.
Okay, so now you know how to multiply, add, and subtract. There's only one last thing to do that's tough at all, and
It
that's
says divide.
divide.
3 minus 2i over 4i.
Before we do that one, I want to do this one.
Okay.
And I'll explain why in a minute. This looks like a division problem. It really isn't. In other words, there's no way I'm long dividing this. What it is I have to make the denominator a real number. You're not allowed to give an imaginary number in the answer of your denominator. In the same way you can't give an irrational number. You can't give an answer like that either. That's also not a division problem. This is a rationalize the denominator problem. How do I rationalize the denominator? By multiplying it by root 2 over root 2, which translates this thing into that. That's okay. It's got the irrational number in the numerator. Nothing wrong with that. You just can't have this irrational number in the denominator. Same thing with imaginary numbers. I'm not really going to divide. What I'm going to do is I'm going to make the denominator a real number. How do I do that? By multiplying by the conjugate. That's the conjugate. Now, I can't just multiply the bottom by some number unless I multiply the top, because now I'm only multiplying that original fraction by the number 1, and you can always do that. And by multiplying the bottom by the conjugate, you're going to lose the I, and it's going to turn into a real number. What is 5 plus 10i times 5 minus 10i?
0.
No, it's that times that, which is 25. And then notice that the next two terms cancel. In other words, that times that is minus 50i, but then that times that is plus 50i. It's always going to cancel. And the only thing I'm left with is the last term, 100i squared. Well, I squared is minus 1, so the bottom turns into 25 plus 100. 125. That's the new denominator. Now, we've got a numerator that we got to come up with, and we come up with the numerator by multiplying that times that. We know how to do that. We just did it as step 1. What was it? Again, let's do it.
So, are you talking about multiplying the denominator?
Yeah, we already multiplied the two denominators, and we came up with 125. So now we need a new numerator. You got to multiply minus 3 plus 2i times 5 minus 10i.
So,
Minus 15.
Minus 30i plus 10i plus 20i squared.
What did this turn into before? Minus 35
Minus 20i.
minus 20i. Well, that's our numerator. Minus 35 minus 20i. Now, what's better about this is it's got the complex number in the numerator, and it's okay to be in the numerator. You just can't have it in the denominator. Now, one last thing. Standard format for a complex number is a plus bi. Well, we don't really have that in that format. But I can split this into two fractions, minus 35 over 125 minus 20 over 125i. In other words, I take this answer that I have circled, split it into two fractions, and now I have perfect format, a plus bi. Okay?
Okay.
Now, let's do the problem you have, which is dividing by 4i. The reason I wanted to do the first one was because that concept of the conjugate is extremely important. What's the conjugate of 4i?
The numerator is 3 minus 2i.
Okay. So I still have an imaginary denominator, and that's not acceptable. So I have to multiply top and bottom by the conjugate of the bottom. What is the conjugate of plus 4i?
Minus 4i.
Now, I actually could get rid of the imaginary number by multiplying by 4i, but it's better to always think of this in the conjugate. That's why I wanted to do the first problem first, is because it's a very important concept to multiply by the conjugate. Okay, what's the bottom become?
Negative 16i squared.
Which is what?
16.
What's the top become?
Negative 12i plus 8i squared, so negative 8.
Okay.
12i minus 8.
Okay, but let's write that in as minus 8 minus 12i. In other words, we want it in standard format, over 16. Now I can simplify that. Let's simplify that. And put it into a plus bi format. What's the a part?
Negative 8.
Negative 8 over 16. In other words, we have to break this up into two fractions. That fraction and that fraction. In other words, 2 plus 3 over 6 is the same as 2 over 6 plus 3 over 6. That's all I'm doing.
Okay.
Okay? It's worth noting, before we go past that, that this is not true. You cannot split it up like this. You can only split it up if your denominator is a single term. Okay?
Okay.
Okay, so in our problem, we had a denominator that was just 16. So I'm going to split this up into minus 8/16, which is minus a half, and then minus 12i over 16. Well, that's 4 goes into that 3 and 4, so that's minus 3/4 I. So there's our answer in proper format. Now, I don't know whether your teacher wants you to do proper format or not, but
Okay.
she may accept this as an answer. Although she wouldn't, because I can simplify those numbers. In other words, I can make that 1 minus 3i over 4, which would be better than this.
Okay.
Okay, what else you got?
It says
You got
find a third degree polynomial with the given roots -1 and 2i.
okay. Imaginary solutions never come alone. They always come in pairs. So if 2i is a solution, what's another solution?
-2i.
Yeah, the conjugate. In other words, if 3 plus 7i was a solution, then I know that 3 minus 7i is also a solution. Because they always come in pairs. They never come alone. So those are our three solutions. So what are our three linear factors?
X plus 1, x minus 2i, x plus 2i.
multiply those three things together, you got your polynomial. And it will be a cubic. In other words, I already know when I multiply those two together, it turns into a real number, right?
Mm-hmm.
Because that's just the conjugate of that. So the I is going to disappear. And then I'll have a binomial term times another binomial term, and I'll end up with a cubic. As long as I got an x there, an x there, and an x there that are all being multiplied, I'm going to end up with x cubed. And I trust that you can do the rest of that multiplication. In other words, do these two first, because you'll get a three-termed trinomial, but it'll be a polynomial. It won't be a complex number. In fact, it'll actually be pretty simple. It'll be x squared minus 4i squared, and that turns out to be x squared plus 4. So it's not even a polynomial. It's x squared plus 4. So let me erase both of these, make it x squared plus 4. I've multiplied them together. Now you know how to multiply that times that?
Yeah, so x cubed plus 4x plus x squared plus 4.
Okay, and the only thing you'd want to do is put that term in front of that term. In other words, you wouldn't want to give that as an answer. Always order your, put the highest degree first, followed by the second highest, followed by the third, and so forth and so on.
Okay.
Now, yeah, no, that's right. So that's our answer. All right. It's 8:15. Why don't we call it a session? I would normally go over a little bit because we had all that dead time in the middle. But unfortunately tonight I have another session that I got to get to. So.
Okay.
Now, I think the reason you almost forgot tonight's session was because we scheduled it at the end of last week, I believe.
Mm-hmm. Yeah.
Do you want to do that same thing?
Yeah.
Let me make sure.
Yeah. You had.
Let me just look next week, make sure I have that spot open. Let's see. So you're at from 7:15 to 8:15 on Tuesday. Yeah, I don't have that in there, but I'll put it in there right now if you like.
Okay. Yeah. Sounds good.
And I'll move it to 7:15. Sound good?
Sounds good.
I will talk to you next Tuesday.
All right. Thanks. Have a good week.
You too. Bye-bye.